Good morning, guys. Trying to get back at it. We're going to start with covering scientific notation. This is 6.5 scientific notation. We didn't touch on this last year, but I think you have seen it before. Here we go. So scientific notation is a compact way of writing very large or small numbers, frequently used by scientists and mathematicians. It's really just a way to write a big number smaller. Okay. One of the things that you want to remember when you're writing in some scientific notation, I'm going to change colors real quick. Yeah, you can remember my coloring changes. Okay. When it's written in scientific notation, for it to be in correct scientific notation, there is one digit in front of the decimal. Okay, so for instance, when I'm looking at this number here, we're going to change the number 284,000 miles to scientific notation. The general form for this is you would have a number, a decimal, and you can have more than two decimal places afterwards, and then it's times 10 to some number. That's the form that it will be looking at. This is the scientific notation form. So if I'm working with 284,000, the decimal right now is located after this 0. I want to move it to where there is only one digit in front of the decimal. So that means I have to move it all the way over to between the 2 and the 8. So how many times do I move it? 1, 2, 3, 4, 5. And since I am moving to the left, when I do this, I'm going to add. So left, you add, or it's going to be a positive number. Or you can think of it as we're going from a big number to a small number, because this is going to be written as 2.84. We drop off the rest of those zeros. And then we have times 10 to the 1, 2, 3, 4, 5. 10 to the 5th. Next example, we're going from a small number. So remember, for this one, we went from big to small. So it is a positive exponent. Here, we're going from small to big. So we're going to have a negative exponent. Can you see what I'm writing? Yes, excellent. Okay, so remember, we only want one decimal place in front of one digit in front of the decimal. So I'm going to move 1, 2, 3, 4, 5, 6. So I know I'm going to have times 10 to the negative 6. And then I'm going to have 2.68. We don't worry about all those other zeros. So we went to the right. Since we went to the right, that means we're going to subtract. The subtract number, that description will make sense as we move along, or it's going to be a negative number, which is also small to big. Those are just multiple ways for you to be able to think about that process. All right, let's work a couple of others. Here we go. We're writing these in scientific notation. Okay, so remember, the decimal starts behind the last digit, and I'm moving 1, 2, 3, 4, 5, 6, 7. So this is going to be 7.5 times 10 to the 7 because it's left. So it's a positive number. Okay, if I'm looking at number 2, I'm going 1, 2, 3. I'm going to the right. So therefore, this is going to be a negative number. So I'm going to have 8.52 times 10 to the negative 3. Moving right along. We're going to jump down a little bit. Let me move some stuff out of the way here. For number 7, now we're going backwards. We're going the other way. We're going from standard form. So we're wanting to write it in standard form. This is standard form. When it's the regular number, it's standard form. This is scientific notation. It's given to me in scientific notation, so I'm moving it back to standard form. So I'm going to now need to move, since this is a positive number, remember, it's a positive number, so therefore I move to the left. So I'm going to move, or actually, no, I'm going to think about that differently. Positive number means I want a big number. Positive means I want big. Well, in order to make this bigger, I'm actually going to move to the right. It's the opposite when I'm going from. So let's make a little note here. Opposite when going from scientific notation to standard form. Okay, so like positive we said would be left, but it's actually we're going to the right because we want to make this bigger. So it's going to be 254. For number 8, that's a negative exponent. So I have negative. That means I want a small number. So therefore I'm going to move to the right. So that means I'm going to the left. Miss Wilson, remember your left and rights. 1, 2. So this is going to be point, and any empty spaces, I put a 0, 0.067. Remember, you can always pause the video and re-listen to any explanations if you need it. Okay, moving right along. So that's going back and forth between standard and scientific notation. Now what we're going to do is add and subtract, multiply and divide with those. Okay. So with this, LARS, it says make sure exponents are the same. That means when you're looking at the exponents, it's 10 squared here, 10 squared here. You want to make sure those are the same. If it's not, you're going to use what's called LARS. Left, that means you add how much you have to move. If you have to move the decimal to the right, then you would subtract. Most of the time we add. It's just easier to add than it is to subtract. Okay, and then you add and subtract the numbers. The big thing to remember is keep the common exponent. Okay, so it's going to be treated just like as if. So treat like it is 3.4x plus 5.2x. You treat it like if the 10 squared and the 10 squared are x. These are like terms. I add them together. Okay, and you treat it that way because it is 10 squared for both. Sorry, my voice kind of gets a little catchy with everything. Excuse me. All right, so here we go. So let's work a couple of these. So if I'm looking at 13, what I'm going to do here is, because these are the 10 squareds are the same, then all I'm really doing is adding the 3.4 plus the 5.2, which is going to give me 4 plus 2 is 6, 8. So I have 8.6 times 10 squared. We just bring down the 10 squared. There's my answer. Okay. Next, let's look at 14. Okay. This is where you should notice the exponents are not the same. Okay. What we want to do, the easiest thing is let's change the second one to be the same as this. Well, in order to get the 6 to the 7, I'm going to add 1. Since I'm going to add 1, that means I'm going to move to the left. So I added, so therefore I move the decimal to the left. So I'm going to go to the left 1. So I'm now going to have 9.5 times 10 to the 7th plus 0.011 times 10 to the 7th. I know this is not correct scientific notation, but we need it written this way so that we can add it together. Okay, so now, excuse me, I add. So I'm going to have 9.5 times 0.011, and we're lucky because you do get to use a calculator with this, but this way you know what's happening. So I have 115.9. Nope, because Miss Wilson obviously can't write her decimals correctly because I wrote this wrong. Please bear with me. All right. So we have, might not be able to use this color too much. 0.11. So we have 9.61, which is going to give me 9.61 times 10 to the 7th. And I always want to check to make sure 9 point, it's not very dark. Let me get that darker. Times 10 to the 7th. You want to always check to make sure that this is correct scientific notation when you get to this point, because you may have to move it around. This is because there's only one digit in front of the decimal. So this is my final answer. Okay, next page. Here we go. We're going to jump around. You know, Miss Wilson likes to jump around on the problems. Here we go. Let's move. We're going to do number 19 together. Okay, now we're pulling in subtraction. You treat it the same way. The exponents on the 10 are the same, so I'm just doing 8.17 minus 2.6, which means I would line up my decimals, or probably punch it in the calculator, and we subtract. So 7 minus 0 I can do. 1 minus 6 I can't do, so I've got to borrow. This becomes a 7, this becomes an 11, so this becomes 5. 7 minus 2 is 5, so we get 5.57 times 10 to the 4th. And there's my final answer. Okay, jumping down to number 23. I'm going to look and see, if I look at this, these are close, but they're not the exact same. I want to see, what do I need to do to move? I want to keep this one the same. I'll move the second one. What do I have to do to get them to be the same? I have to add 2. Since I'm adding 2, that means add, I've got to move to the left. So I'm going to move to the left twice. 1, 2. Remember, any spots that are left empty, we will put a 0. So these are going to be rewritten as 2.8 times 10 to the 1 minus 0.084 times 10 to the 1. And now I can do my subtraction of 2.8 minus 0.084, which this is where we have our handy dandy calculator, because you get the picture with the, this is why we get to use a calculator. 2.8 minus 0.084, enter. And if you would not, you would put your zeros and you would have to borrow. This would have to become 79 and this is 10. So we get 617.2. So we have 2.716 times 10 to the 1 as our final answer. Okay, that was addition and subtraction. Now we have multiplication and division. I think this video is going to be long. It's been a while since I've done these. Okay, but this is also something we didn't cover last year. So take breaks when you need, but just make sure we get through all of it, learning it. Okay, so we're going to multiply and divide. Use the product and quotient rule to change the exponent. Okay. So when I'm looking at this, that's where you've got to remember for the product, you add. For the quotient, you subtract the exponents. Add or subtract the exponents. That's what I believe you've just got through learning. So use LARS to adjust the decimal and exponent in the final answer if needed. Okay, with these, we're going to do several of these so we have an example of all. Okay, so for 2.5, 2.5, 25, the way I like to think about these is to separate them out. So I'm going to have not 0.28, it's 2.8 times 1.9 times, and then this is because the exponents, the base is the same, so I'm going to have 10 to the 7 plus 4. So now in the handy dandy calculator, I'm going to do 2.8 times 1.9, which gives me 5.32. I don't have to worry about changing this because this is correct. It's one digit before the decimal. Times 10 to the 7 plus 4 is 11. There is my final answer. Again, if you've got questions or need to listen to it again, pause it or come and see me. All right, next, 27. Okay, we're multiplying again. So I'm going to have 3.4 times 8.5 times 10 to the, since I'm multiplying, that means I'm adding, so I'm going to have negative 2 plus 6. Okay, so now the next part, I'm going to do that multiplying 3.4 times 8.5, and that gives me 28.9 times 10 to the 4th. But my problem is, this is not correct scientific notation. There's 2 decimal places in front of the 2 digits in front of the decimal. So I have to move to the left 1. So since I am moving left, that means I'm going to add. So I add 1, and we end up with my final answer of 2.89 times 10 to the 5th. Again, if you need to watch that again, pause it and rewind. All right, 2 more and then we're done, guys. Okay, for 29. All right, we're doing division now. Okay, I reset these up to where I have 3.72 divided by 1.2 times 10 to the, since I'm dividing, that means I'm subtracting the exponent, so it's going to be 8 minus 5. Equals, so I have 3.72 divided by 1.2, which gives me 3.1 times 10 to the 8 minus 5 is 3. I don't have to move my decimal because this is correct scientific notation. I'm done with 29. All right, moving right along. Let's look at 31. It's already in this division form for me here. So what I can just do is, okay, but what I have to pay attention to here is I'm subtracting a negative 6. Okay, so I've got to do, since I'm subtracting a negative 6, that means I'm actually doing 1.2 divided by 5. So I'm going to do this division right here. So that's going to give me 0.24 times 10. So that's negative 5, double negative, so that becomes a big plus 1. But this is not correct scientific notation. I have to move to the right. So since I am moving make sure you can see it. Write 1. I'm going to subtract 1. Subtract 1, which is going to give me 2.4 times 10 to the 0. Actually, guys, we don't write this times 10 to the 0. This is normally not written. If you write it, I would not mark it wrong. But your final answer for this is going to actually be just 2.4. Okay, you've got several examples to look at. Your assignment is to finish the notes and the classwork homework. You'll have a great day. Bye.